Hello students, next we move to the last part of this module where we are discussing about the magnitude and phase of the network functions. So let us look at this problem. Evaluate the amplitude and phase of the network function f of s from the pole 0 plot at s is equal to j2. So it means that they are asking us to find out the amplitude and phase of the network of the function from the pole 0 plot. Now there are two methods of doing it. First method is quite easy. The second method is a graphical method. Okay, so how do we do it? I will show both the methods. The second method is a graphical method. The first method, it's as such not named, but I will call it as substitution. Substitution method. Where, sorry, where I am basically going to take f of s, and instead of s I am going to replace it by 2j or j2, whatever. Now before I do that, I should always remember that first I have to always make my function in this form. F of s is equal to h, then s plus z1, s plus z2, like that all the way up to s plus zn, whereas in the denominator it will be s plus p1 into s plus p2 all the way up to s plus pn. We have to make it into this form. Now when I am saying into this form, even if this denominator and numerator is some polynomial, that is also okay. So if it is some polynomial, then also it's okay. For which method? For the substitution method. So what do we do is, we write this as, first let me write this as that. So here I will get f of s is equal to 4, then s divided by s square plus 2s plus s2. Now what I have done, all I have done is I have kept the coefficient of the highest power of the numerator as 1. That is what I have done here. Similarly, in the denominator also I can do that, but here there is no requirement. So once we have got it in this form, then what we do is the substitution method, wherein we basically take s and substitute it as 2j. Why 2j? Because in the question it is asked us to find out the value of amplitude and phase at s is equal to j2 or 2j. Okay, so if I am going to substitute that, I will get 4 2j divided by 2j square plus 2j into 2 plus 2, which will give me 4 times 2j divided by 2j square becomes minus 4 plus 4j plus 2, which minus 4 and plus 2 I can write it's going to be 4 into 2j divided by minus 2 plus 4j. So now if I am trying to take the magnitude of f of 2j, if I am trying to take the magnitude, then I will take the magnitude of each and every component. So 4 as such magnitude will be 4 because it's a real number. 2j I would want to take the magnitude, and the denominator minus 2 plus 4j also I would want to take the magnitude. Generally, let me write the equation. Generally, if you are having to take the magnitude of some x plus jy. What is the equation? The equation is under root of the real part square plus the imaginary part square. So if I am having even minus 3 plus j minus 2, that also I will always write it as minus 3 square, which will become 9, plus 2 square, which is 4. So it will be under root of 13. Now if the first term is 0 plus, let's say, j of minus 5, what is it going to be? Under root of 0 square plus 5 square, which is basically 5 itself. So if you are having only the real part or only the imaginary part, the magnitude of that will be that same number, but it will be always positive. Always it will be positive. Why? Because it is getting squared and then it is getting under root. So here, what will we get? Here we will get the magnitude of f2j as 4 into, what is the magnitude of 2j? Under root of 0 plus 2 square, which again it will come as 2 only, isn't it? Divided by under root of minus 2 square plus 4 square, which comes out to be 4 into 2 divided by under root of 4 plus 16 is 20. The answer of which I will get it as 1.789. Similarly, if I want to find out the phase angle of f2j, all I have to find out is the angle of 4, which is always going to be 0, because the real number always it is going to be, the angle is going to be 0 for a real number. So I will not write that. Okay, for the h part I won't write. Whereas for 2j, so I will write angle of 2j divided by the angle of minus 2 plus 4j. So all you have to do is you have to do the rectangular to polar conversion. Okay, so if you do the rectangular to polar conversion, you will get what is the value. So if I am going to do the rectangular to polar conversion of this one, 2j, then you can do 2j shift of from polar to rectangular. In your calculator you can do, and you will get the answer as 2 angle 90 degrees. So what we have done, we have done the rectangular to polar conversion. So R to P, rectangular to polar conversion of 2j, which gives me 2 angle 90 degree, out of which I am only interested in 90 degree, correct? So I can directly write this as 90 degree in the numerator, 90 degrees in the numerator, and in the denominator, again if I do the rectangular to polar conversion of minus 2 plus 4j, if I am going to do the rectangular to polar conversion, let me write it here, I will get 4.47, let me write it in order. So if I am going to take the rectangular to polar conversion of minus 2 plus 4j, if I am going to do the rectangular to polar, then I will get 4.47 with an angle of 116.56 degrees. So that angle only I am interested in. So I will write the angle as 116.56 degrees. And we know that if angle has to be divided, it's not basically division, it is 90. So I should not write it like this. I should always write it as, when it is division, I should always write the angle as minus, isn't it? So I will write, I should not have written it like this. I will correct it. I will write this as 90 degree for the numerator minus, why minus? Because it is division here. Minus, what is the angle? 116.56 degrees. So if I am going to minus that, so I will get 90 minus 116.56, and that answer will come out to be minus 26.56 degrees. Minus 26.56 degrees. So this is the substitution method. Now actually there is a very easy method for doing this again. All you have to do is, let me, like, it is for you to check if you have done correctly. All you have to do is take the calculator, calculate F2j as 4 into 2j divided by minus 2 plus 4j. You just do that and you will see, use a calculator, just use a calculator and solve this. You will get that answer as 1.789 with an angle of minus 26.56 degree, where this is the magnitude part that we have just now discussed, and this is the angle part that we had just now discussed. So in a way you can check that answer also. So directly you can get this answer. Now what is the graphical method? Because we are actually in your syllabus, it is basically discussed as the graphical method. So what is the graphical method of doing it? Let me write that here. So f of s is going to be, it's already given as 4 into s divided by s square plus 2s plus 2. So this is the h, and then we are having the numerator polynomial and we are having the denominator polynomial. The first thing that we have to do is we have to find out the poles and zeros. So the numerator is already done, so it is s, and now using quadratic equations we can find out what is the roots of this, and you will, if you use a calculator, you will get the value as s is equal to minus 1 plus minus j 1, okay, plus minus j, which actually you can write it by bringing this the other side. You can write it as s plus 1 plus minus j is equal to 0, okay, which you can write it as 2, because already the degree is 2, so there are 2 poles. The poles are at s plus 1 plus j and s plus 1 minus j. Okay, so where are the poles? The poles are at, so let me draw that, because in graphical method what we do is we draw it. So now if I am going to draw this, so let me draw it using a different color. The pole is at the origin, so that I am going to draw, and then let me draw, this is suppose minus 1, let me write it little bit side, okay. This is minus 1, this is minus 2, this is minus 3, this is minus 4. Similarly here you can write j, you can write it as j, 2j, 3j. This is which axis? J omega axis. This is real axis, so I can write 1 here, 2 here, 3 like that. This is going to be minus j, minus 2j, minus 3j like that. Now where is your pole? The pole is at s is equal to minus 1, this one, minus 1 plus minus 2j. So again I will use this one, and I can draw this as, this is the point, where it is minus 1 plus j. So there you are having 1, and similarly here you can draw the second one, which is minus 1 minus j. So this is the second one. Okay, now let me rub off the lines that connect it, because no need for you to draw it. I will basically just draw only the poles and the X marks. Okay, so these are the poles and the zeros of this network function f of s. Now we are asked to find out what is the value at s is equal to j. So I will write that at s is equal to 2j. So where is 2j? 2j is here. So here let me draw it as a bold point. Sorry. So this is 2j, and from every pole and 0 I will draw a line. From every pole and 0 I will draw a line. So these are the lines that I have drawn from the pole and the zeros to, sorry, this is a mistake. Yeah, from pole I have to draw it. So this is minus 1. Yeah, from pole I have to draw it towards the point that they have mentioned here, which is what? 2j. So towards 2j I have drawn all the lines. Now see, if I am going to expand this, let me expand this because I want to explain it to you. Okay. See, now if I am going to look here, you see the real axis. You have to draw a real axis for each and every one of them. So this is the real axis. Okay. For this pole, this is the real axis. See, I am drawing the real axis in the same direction as sigma. And then here you are going to have the magnitude. So let me use a different color. Okay, so this angle is the angle that I am interested in, and the black dotted line is the length that I am interested in. So let me use a different, instead of drawing it as dotted one, what I will do is I will use solid lines, because otherwise it will not look, or you will not be able to understand it properly. So if I am going to use solid lines with the black color. Okay, so now from here I will draw one phasor towards the point 2j. Okay, similarly I will use another one to draw from here to point 2j. Correct, and the last is from the pole. So before that, let me okay, so the pole was at this point, and I am going to draw the length from here to here. Okay, and what is the angle? The angle of this one is this much, which is obviously 90 degrees. So now what is the equation that we use? Okay, so this is the magnitude. So I can write, since this is the 0, so I can write this is the magnitude of 0 and this is the angle of 0. We have got two poles. This I will write as the magnitude of pole 1, and this angle I will write it as the angle of pole 1. This I will write it as the magnitude of pole 2. This I will write as the magnitude of pole 2, and this angle I will write it as the angle of pole 2. Okay. Now let us look at the equation. Let me zoom out. Okay. Now what is the equation that I am going to write? The equation is that I will have to write the magnitude of f of 2j, that will be h into the product of phasor magnitude from all zeros to 2j, similarly divided by the product of phasor magnitudes from all poles to 2j, from all poles to 2j. Okay, that is the network function value. So how many poles we are having here? We are having only one pole. For our case, it is only one pole. If suppose there would have been multiple pole, I would have got the magnitude as Z1's magnitude, then I would have got Z2 magnitude, then I would have got Z3. If suppose there are 3 poles, I have to multiply each and every one of them. I have to multiply all of them. Similarly, if I have got poles P1 magnitude, I will multiply it with P2, and if there is suppose a third pole, but here we are having only one pole, so what I have to do is I have to multiply with the magnitude. Now look at the magnitude. I am only looking at the length. I am not looking at the direction. I am only looking at the length. So from here, this was j and this was 2j. So this length is going to be, this length of j is going to be 2. Similarly, the pole, this length of P1, let's say this length of P1, how will I calculate it? See, I can calculate it using the Pythagoras theorem, because in the Pythagoras theorem, this, if suppose this is x and this is y, then this will be under root of x square plus y square, correct? So here this length is 1 and this is 1, 2, 3. So it is under root of 1 square plus 3 square. And similarly, what about this P2? Again, if I am going to draw the triangle will be, this one is 1 and this distance is going to be again 1. So it is going to be under root of 1 square plus 1 square, which is going to be root 2. So I will write here as root 2. Okay, which gives me h is how much? 4. So which gives me 4 into 2 divided by root of 10 into root of 2, which is again 4 into 2 divided by root of 20. See, this is the same one we had got previously. Listen, this one, the substitution method, we had got the same value. So that same thing we will get here. And what is the angle? What is the equation of the angle? The angle is, the angle of f of 2j is going to be the angle, summation of the angles of all the zeros. So I will write zi. So this is going to be I is equal to 1 to, how many zeros we have? N zeros, minus summation of the angles, I is equal to, not, let's say L, okay, L is equal to 1 to M, and angle of all the poles PL. Okay, so what is the angle here? So how do you find out the angle? Now here we can get the angle is directly 90 degree. There is no issue. So the pole will be having an angle of 90 degree. That is not a problem. What about this angle? Again, this angle, I drew the triangle. The triangle was basically 1 and 3. So if I want to find this angle, I can write it as tan inverse of 3 by 1. See, in that case, always take care that if suppose the angle is coming in negative, that means if the triangle would have been something like this, then this would have been, 1, and this would have been -3. Why? Because it is going down. Okay, so whenever we are drawing any arrow, see, suppose here I have drawn the arrow, I have drawn it like this, so it means that I am going like this and I am going like this. So this is +3 direction and this is +1 direction. If suppose instead of going like this, I would have gone in an opposite direction, if suppose I would have drawn the arrow like this, then for coming from here, it is going to be down arrow, which is going to be a negative value, and similarly a back arrow, which is going to be again negative. So this will be some negative value, this will be some negative value, similarly this also will be some negative value. So I have to write tan inverse of some negative, let's say this is -x and this is -y, so I will write -x divided by -y. That is what I have to do for getting the angle. Which angle? For getting this angle, or which is basically this angle. Okay, so you have to take care based on the direction of the arrow, you have to take care of that. So here I have got tan inverse of 3 minus 1, and for this one I will get, again the triangle is 1 plus 1 and plus 1, so it is going to be tan inverse of 1 by 1, tan inverse of 1 by 1. And what about the top one? The top one, it's directly 90 degrees, correct? So I will write, therefore angle of F2j is the summation of poles, summation of angle of poles. So the angle of 2 is 0, 2j is 0, 90 degree. So this is 90 degree. Where did I get that 90 degree? I got the 90 degree from here. Always see, the angle always is taken as anti-clockwise, it's positive. So whenever I am going to take the angle, it is going to be positive. Or you can look it like this. See, this is also a triangle. This arrow is also a triangle with x is equal to 0 and the y is whatever is the value of y. So tan inverse of y by 0, which is tan inverse of infinity, which comes out to be 90 degree. So instead of y, if we keep 2, we'll get that. So 90 degree minus, what is the summation of the angles? That one of the angle is tan inverse of 3 by 1 plus tan inverse of 1 by 1, which will actually give me the same angle which I had got previously, which was minus 26.56. You can do this. You will see that it is going to be minus 26.56 degrees. Now, generally you will be asked in the exam to do it in the graphical form. Okay, generally in the exam it will be asked to be done in graphical form. When you do it graphical form, these are the steps to follow. But obviously you can always check whether you have got the right answer or the wrong answer, whether you have got the magnitude and phase part correct by just using a calculator, and you will get the answer then and there itself. So there is always an advantage that you can check whether your answers are correct or not. Okay, so this is what is the phase amplitude and phase. Another kind of problem that is very rarely asked, but since it's there in the syllabus, I will surely teach you, is something of this form. Plot the amplitude and phase response for f of s is equal to s plus f of s is equal to s divided by s plus 10. Now generally this comes under the category of something that is called as Bode plot, but I'm not going to discuss it here because Bode plot is actually out of your syllabus. You will discuss Bode plot in control system, another subject. So generally it should be done using Bode plot, but here they are not teaching you Bode plot. They are just asking what is the amplitude and phase response of a function that is given by this. How you do this is very simple. It's a very simple procedure. Substitute or put s is equal to j omega. You have to substitute fs is equal to s is equal to j omega. So if I am going to write that, I will get f of j omega is equal to j omega divided by j omega plus 10, from which therefore the magnitude of f of j omega is going to be the magnitude of the numerator, which is omega. Why? Because I already told you x plus jy, the magnitude is going to be x square plus y square. And what is the angle? Angle is the phase angle is, so this is the magnitude. The phase angle of x plus jy is going to be tan inverse of y by x. So the same principle will apply here. So it is going to be j omega, it's going to be 0 square plus omega square, the whole under root, which comes out to be omega. Similarly here it is going to be 10 under root of 10 square plus omega square. 10 square plus omega square. That is the magnitude. And what about the phase angle? The phase angle is going to of f of j omega is going to be, the phase angle of j omega is going to be, again it's going to be tan inverse of omega by 0 y by x, isn't it? Tan inverse of y by x, which is omega by 0, divided by tan inverse of omega by 10. Omega by 10. It should not be written as division, sorry. I should always, in the case of angles, it is always, yeah, it's not division, it is always going to be minus. So minus the tan inverse of omega by 10. Always remember this formula that we have already done here. You know, this formula is for the angular part. So based on that, this is what we have got. Now, if I am going to plot the magnitude of, if I am going to plot the magnitude, so let me draw it properly. So I will draw 3 rows. One is for omega, another is for the magnitude of f of s, and the third one is for the phase part. So I will write here, this is going to be omegas, this is going to be the magnitude of f of j omega, and this is going to be the angle of f of j omega. So this is what we are going to plot. So how do we plot it? So we can always start it from, people always start the plot from 0. So generally what we do is we start from 0, then we go to 10, then we go to 100, then we go to 1000, and even if we want to go up, we can go to 10 raised to power 4, which is 10,000. So each and every case I will have to substitute the value of omega in this equation and this equation to find out the magnitude. So what is omega is equal to 0? If I would put here, this one will give me 0, and here the magnitude, the angle of this one would be tan inverse of infinity, which is 90, correct? So this is going to be 90 degrees. Similarly, if I am going to put 10, so here I will get 10 divided by under root of 10 square plus 10 square, which is 10 divided by under root of 200, which if you would see, it's 1 by root 2, which comes out to be 0.707. And similarly, if I am going to put here, see, tan inverse of omega by 0, it will always come as 90, no problem. Minus, so 90 minus, here I will have to put omega is equal to 10, so 10 and 10 will give me 1. Tan inverse of 1 is going to be 45 degree. So 90 minus 45 degree is going to be 45 degrees. Similarly, if I am going to put 100, the value I will get is 0.995, and omega, if I put 100, again I will get 90 degree minus tan inverse of 100 by 10, which is tan inverse of 10. So that if I would do, I will get the angle as 5.7 degree. Similarly, I will get for 1000, if I do, I will get 1, and then I will get here I will get the value as 0 degree. Now if I am going to keep on doing that, if I am going to keep on doing that, what I will get always is, I will get, if I am going to further go down, I will get the value as 1 and 0 degree for this case. So if I am trying to plot this, so I am having two plots. One is the magnitude plot, and the second one is the phase plot. Okay, so it can have even negative direction also, but magnitude will have always positive. So I will draw it like this, that I am having this is the magnitude of f of j omega, and this is the angle of f of j omega, and this is the omega axis, and in omega I will take this as this is 0, this I will take it as 10. Even people take 1. If you want to take 1, it is okay. 1, 10, it is the multiples of, I will always start with 10. It's always the multiples of 10. So it is going to be 10, 100, 1000, like that. Okay, and you can see here it starts from 0. Then goes to 0.707, then it reaches 0.95, and then it becomes 1. So if I am going to draw this plot, I will get the plot of magnitude plot, I will get something like this. Whereas if I am going to draw the angle, then angle again it will start from 90. So this is 180 plus 180, and this is suppose minus 180. Then I am suppose starting at 90. So I am suppose starting at 90 degree. So for 0 I will get 90. For 0 I will get 90. For 10, so this is again 10. This is 100. This is 1000. So like that if I am going to get. So 0 it is 90. Then it becomes straight half 45. Then it becomes 5.7, then it becomes 0. So like that it is going. So that I will draw it something like this. Now if you want to properly draw it, you will require a semi-log graph, because only in a semi-log graph you will be able to put these values as 10, 100, 1000, 10,000, like that. But semi-log graph, again you will have to go for Bode plot, which actually is not there in your syllabus. So generally these kind of questions are generally not asked, but for you to understand that amplitude and phase response is got something like this, and this is what is used for basically filter design. See, all of this we are studying for basically learning the filter design. What is filter? With that I will stop it. So what is filter? So suppose if you are having a frequency plot. Now here it is omega, let me write this as frequency f, and this is some magnitude m. What is a low pass filter? Low pass filter will consist of lower frequencies and it will not take higher frequencies. What is a high pass filter? High pass filter will basically avoid low frequencies and only accept high frequencies. What is band pass filter? It will accept only the in between frequencies. It will neither accept the high pass values, neither it will accept the low frequencies. So this is what is a band pass filter, isn't it? Band pass, this is going to be high pass filter, and this is going to be low pass filter. So how it is going to behave in frequency is going to be dependent on its magnitude phase plot. So what we have got here is, this is basically what? This is basically a low pass filter because it is not accepting low frequencies that much. Sorry, this is a high pass filter. It is not accepting low frequencies that much. So that's why this will be looking like a high pass filter. So like that, slowly you are being entered into a, you are given a concept that suppose if you are having any circuit, that circuit you can find out what is the, so if it's a two port network, so that you can find out what is the transfer function, let's say V2 by V1. So you can find out what is V2 by V1, and from that V2 by V1 we will say that this is the network function f. That network function f will have a magnitude and phase, and from which you will get this magnitude response as well as this phase response, from which you will be able to say whether this is a high pass filter, whether it's a low pass filter, whether it's a band pass filter. Okay, so all you are starting from basic resistance, capacitance, inductance circuit, but you are getting the network function f, from which you are directly able to say whether it's a low pass, high pass filter or not. Okay, so this is basically why we are having this portion. Generally it is not that much asked in exam because if at all it is asked as a theory portion. Okay, so with this we will finish the fourth module. There is one more topic that is remaining in the fourth module. It's a very small theoretical topic, but that I will be able to do only after I complete the remaining portion of the third module. So next class onwards we will start with the remaining portion of the third module that we had to leave because of the length of the module. Okay, thank you.